Hello, we want to solve for W in these logarithmic equations. Here our variable is W and not the usual X that we find everywhere, but it's the same method of solution. So let's take the first one. Log to the base 4 of 2W plus 1 minus log to the base 4 of 3W minus 2 equals 1. Now, we know the law of logarithm, which says log a base b minus log x base b. That law simply says that we're going to write log a all over x base b. Okay, so what do we have here? Remember, the bases are the same, so we have the bases the same, and then a here is the expression 2w plus 1. X here is the expression 3w minus 2. So let us write everything, the left hand side, in this form. So we're going to have log of 2w plus 1 all over 3w minus 2 all to the base 4 is equal to 1. Okay? When we apply that law, right? Now, what do we see? From the rules of logarithm, the rules relating logarithms and indices, if we raise this base to this power, we're going to get the argument. That means 4 raised to the power 1 is going to give us 2w plus 1 all over 3w minus 2. All right? Now, 4 to the power 1 is just the same as 4. 4 to the power 1 is just the same as 4. So we leave it as such. And again, 4 in fractional form can be written as 4 all over 1. We're writing it in such a manner because the right hand side is a fraction, so that we can carry out cross multiplication, right? This denominator multiplied to the numerator there, so we have 4 into 3w minus 2. This denominator, look at the arrow, multiplies to that numerator. So 1 multiplied to anything just leave us with the same expression. All right, so we end up with this linear equation to solve. All right, so let's open the bracket. 4 multiplied to 3w gives us 12w. 4 multiplied to negative 2 gives us negative 8, equals to 2w plus 1. So we now bring like terms together. We take the w, this w term to come and meet this w term, and then this constant term to go and meet that constant term. All right, so this is plus 2w. Bringing it over will become negative 2w. All right, this is negative 8. Taking it to the right hand side, there was already a positive 1 here. Negative 8 going to the right hand side become positive 8. All right, so we have 12w minus 2w gives us 10w, and 1 plus 8 gives us 9. Therefore, to have w, we have to divide both sides by 10. So that 10 cancels, leaving us with the value of w as 9 all over 10. Okay, so that is the solution of the first exercise. Okay, let's look at the second exercise. Let's look at the second exercise. We have log w base 4 minus log w base 2 is equal to negative half. Okay, here pay attention, we don't just rush to apply the rule that we used in exercise A above. Okay, the rule that we used in exercise A was applicable because the bases were equal. But here, even though we're doing subtraction, like we did subtraction up there, the base here is 4, the base here is 2. So that rule is not applicable until we bring the bases to the same value. The bases should be on the same value, then we can apply that rule that we use in exercise A. All right, so we know that 4 is the same as 2 squared. So this can be written as log w to the 2 squared minus log w to the 2 is equal to negative half. All right? There is that rule in logarithm which says log x to the a to the n will give us 1 all over n log x to the base a. Okay? So when we apply this to this member of this equation, this member, we have 2 to the power n, a to the power n. What happens to the n? We get the reciprocal multiplied to the log. So we're going to get the reciprocal of 2, which is a half. So we're going to have a half log w to the base 2 minus log w to the base 2 is equal to negative half. Okay? All right? So what do we get here? A half log w to the base 2 minus a half minus log w to the base 2. All right? That gives us from the law of what we have here, this law. Pay attention, pay attention. The law that we have that n log x base a is log x to the power n base a. Okay, now this goes as power. So this half here is going to go as the power of w. This half here is going to go as the power of w. So we're going to have log w to the power half base 2 minus log w base 2 is equal to negative half. All right? Okay. Now we have the same basis. We have arrived at the same base, so we can now apply the law of subtraction that we used earlier with exercise A. So this will give us log w to the half divided by w base a is equal to negative half. All right? Okay, so what do we now do? We now apply the rule that moves from logarithm to indices. It says when we raise this base to this power, we're going to have the argument. The argument is all of this. Okay? Now, what do we then get? We now have 2 raised to the power half. This 2 raised to this power, negative half. 2 raised to the power negative half. We're expected to give us w to the half all over w. Okay? So let's wipe up here. So let's carry this expression again up there. We have 2 to the negative half is going to give us w to the half all over w. When we look at the right hand side, when we apply the laws of indices, we see this is an index number whose base is a half. An index number whose power is a half, and the base is w. This is also an index expression. The power is 1. Remember, if nothing is written, we know the power is 1, and the base is w. So this is w to the half divided by w to the 1. From the laws of indices, when we're dividing index expression that have the same base, we subtract the powers. This becomes w to the half minus 1, which gives us w to the negative half. So finally, we have 2 to the negative half, giving us w to the negative half. Okay? We have arrived at an equality of 2 index expressions. Once more, we have to check. If we say this index expression is equal to this index expression, then we expect that the bases must be equal and the powers must be equal. Now, when we look at the bases, here the base is 2, the base here is w. Okay? But when we look at the powers, the power here is negative half, the power here is negative half. Okay? So since the powers are equal, it means that the bases must be equal. So that implies, therefore, that 2 must be equal to W. All right? So that gives us our solution to the second equation. All right? So I hope you have understood. If you have questions or preoccupations, please don't forget to post them on the comment section. Okay, that solves question B. Now, let's look at the last exercise, question C. Let's look at the last exercise. Question C says 3 log W base 7 is equal to 2 log 7 base W plus 5. Okay, here we have something new also that we are going to observe or that we're going to work with. The base here is 7 and the argument is W. Here it is reversed. The base is W, the argument is 7. So quickly, we need the law of change of base, which says if we have log A base B, then the law says that we can write this as 1 all over log B base A. Okay? This is a law of change of base wherein the argument becomes the base and the base becomes the argument. The base here is B, here it is now the argument. The argument here is A, now here is the base. So we're going to use this law on one of them so that we should have a uniform expression with the same base and the same argument. So if we leave this one and apply that law here, we're going to have 3 log W base 7 is equal to 2 into, we're applying the law here now. Pay attention, we're applying the law here into 1 all over log W base 7 plus 5. Okay, so this gives us 3 log W base 7 is equal to 2 multiplied. So we have 2 all over log W base 7 plus 5. Okay, now we have here an equation in terms of log W base 7. So let's make that substitution. Let's make Y be log W base 7. So wherever we see log W base 7, we put Y. So our expression there becomes 3Y is equal to 2 all over Y plus 5. All right? Now, we don't want fractions. How are we going to remove this fraction? We have to multiply all through by Y. We multiply here by Y, multiply here by Y, multiply here by Y. So we have Y into 3Y is equal to Y into 2 all over Y plus 5 into Y. All right? Y multiplied to 3Y gives us 3Y squared. Here, Y cancels. We're left with 2 plus 5Y. Okay? Now, let's continue this way. All right, let's write this expression down here again. We have 3Y squared is equal to 2 plus 5Y. Okay, if you look at it, you see it's a quadratic in terms of Y. So let's bring everything to the left-hand side. We have 3Y squared plus 5Y coming over becomes minus 5Y plus 2 coming over becomes negative 2, so that we should have 0 on the right-hand side. This is a quadratic. We're solving this quadratic. Our A is 3, our B is negative 5, our C is negative 2. So Y equals minus B plus minus root B squared minus 4AC all over 2A. So let's put in the values of A, B, and C. So this gives us negative y is negative b, negative b is negative 5. So we have negative b plus minus root b squared minus 4ac, all of this divided by 2a. We have negative multiplied to negative is 5 plus minus the root of negative 5 squared, 25. Negative multiplied to negative plus 4 multiplied to 3 is 12. 12 multiplied to 2, 24. All over 6. So you have 5 plus minus root 49 all over 6. All right? So this means y is equal to 5. We take the plus root 49 is 7 all over 6, which is 12 all over 6, which gives us 2. All right? Or y is equal to 5 minus 7 all over 6. This gives us negative 2 all over 6, which is negative 1/3. Okay? So we have the two values of y as 2 and negative 1/3. All right? Pay attention. This is not the solution to our question. Our question is asking us to solve for w. Okay? Our question is asking us to solve for w. So we have to go back to the relation that we made earlier on that brought in y. What is that relation again? The relation we made earlier on that brought in y. Okay? But y is log w base 7. This is the relation between y and w. We're going to put in the values of y in turn, and then we'll be able to work out the value of w. So when y is 2, that means we're going to put 2 here. We have 2 is equal to log w base 7. 2 is equal to log w base 7. Okay? This therefore means that what? 7 raised to the power 2 will give us w. Okay? So 7 to the power 2 will give us w, which means that w is 49. That's our value for w, the first value. And then we now take the other situation. When y is equal to negative 1/3. All right? Again, we're going to put negative 1/3 here, the value of y. Negative 1/3 is equal to log w base 7. Okay? So we have negative 1/3 is equal to log w base 7. Okay? Again, just like we did here, okay, this base raised to this power will give us that argument. Okay? So we're saying 7 raised to the power. This therefore means that 7 raised to the power minus 1/3 will give us w. All right? So if we interpret this carefully, power 1/3, power negative 1/3 means 1 all over 7 to the 1/3 is w. And power 1/3 means cube root. So we have 1 all over cube root of 7 will give us w. So our second value for w is 1 all over the cube root of 7. Okay.